What is network topology? Topology defines the structure of the network of how all the components are interconnected to each other. There are two types of topology, physical and logical topology. Types of network topology. Physical topology is the geometric representation of all the nodes in a network. There are 6 types of network topology, which are bus topology, ring topology, tree topology, star topology, mesh topology, hybrid topology. 1. Bus topology. Bus topology. The bus topology is designed in such a way that all the stations are connected through a single cable known as a backbone cable. Each node is either connected to the backbone cable by drop cable or directly connected to the backbone cable. When a node wants to send a message over the network, it puts a message over the network. All the stations available in the network will receive the message whether it has been addressed or not. The bus topology is mainly used in 802.3, Ethernet, and 802.4 standard networks. The configuration of a bus topology is quite simpler as compared to other topologies. The backbone cable is considered as a single lane through which the message is broadcast to all the stations. The most common access method of the bus topologies is CSMA, Carrier Sense Multiple Access, CSMA. It is a media access control used to control the data flow so that data integrity is maintained, i.e., the packets do not get lost. There are 2 alternative ways of handling the problems that occur when 2 nodes send the messages simultaneously. CSMACD, collision detection, is an access method used to detect the collision. Once the collision is detected, the sender will stop transmitting the data. Therefore, it works on recovery after the collision. CSMACA, collision avoidance, is an access method used to avoid the collision by checking whether the transmission media is busy or not. If busy, then the sender waits until the media becomes idle. This technique effectively reduces the possibility of the collision. It does not work on recovery after the collision. Advantages of bus topology: low-cost cable. In bus topology, nodes are directly connected to the cable without passing through a hub. Therefore, the initial cost of installation is low. Moderate data speeds. Coaxial or twisted pair cables are mainly used in bus-based networks that support up to 10 Mbps. Familiar technology. Bus topology is a familiar technology as the installation and troubleshooting techniques are well known, and hardware components are easily available. Limited failure. A failure in one node will not have any effect on other nodes. Disadvantages of bus topology: extensive cabling. A bus topology is quite simpler, but still it requires a lot of cabling. Difficult troubleshooting. It requires specialized test equipment to determine the cable faults. If any fault occurs in the cable, then it would disrupt the communication for all the nodes. Signal interference. If 2 nodes send the messages simultaneously, then the signals of both the nodes collide with each other. Reconfiguration difficult. Adding new devices to the network would slow down the network. Attenuation. Attenuation is a loss of signal leads to communication issues. Repeaters are used to regenerate the signal. 2. Ring topology. Ring topology is like a bus topology, but with connected ends. The node that receives the message from the previous computer will retransmit to the next node. The data flows in one direction, i.e., it is unidirectional. The data flows in a single loop continuously known as an endless loop. It has no terminated ends, i.e., each node is connected to other node and having no termination point. The data in a ring topology flow in a clockwise direction. The most common access method of the ring topology is token passing. Token passing, it is a network access method in which token is passed from one node to another node. Token, it is a frame that circulates around a network. Working of token passing: a token moves around a network, and it is passed from computer to computer until it reaches the destination. The sender modifies the token by putting the address along with the data. The data is passed from one device to another device until the destination address matches. Once the token received by the destination device, then it sends the acknowledgement to the sender. In a ring topology, a token is used as a carrier. Advantages of ring topology: network management. Faulty devices can be removed from the network without bringing the network down. Product availability. Many hardware and software tools for network operation and monitoring are available. Cost. Twisted pair cabling is inexpensive and easily available. Therefore, the installation cost is very low. Reliable. It is a more reliable network because the communication system is not dependent on the single host computer. Disadvantages of ring topology: difficult troubleshooting. It requires specialized test equipment to determine the cable faults. If any fault occurs in the cable, then it would disrupt the communication for all the nodes. Failure. The breakdown in one station leads to the failure of the overall network. Reconfiguration difficult. Adding new devices to the network would slow down the network. Delay. Communication delay is directly proportional to the number of nodes. Adding new devices increases the communication delay. 3. Star topology. Star topology is an arrangement of the network in which every node is connected to the central hub, switch or a central computer. The central computer is known as a server, and the peripheral devices attached to the server are known as clients. Coaxial cable or RJ45 cables are used to connect the computers. Hubs or switches are mainly used as connection devices in a physical star topology. Star topology is the most popular topology in network implementation. Advantages of star topology: efficient troubleshooting. Troubleshooting is quite efficient in a star topology as compared to bus topology. In a bus topology, the manager has to inspect the kilometers of cable. In a star topology, all the stations are connected to the centralized network. Therefore, the network administrator has to go to the single station to troubleshoot the problem. Network control. Complex network control features can be easily implemented in the star topology. Any changes made in the star topology are automatically accommodated. Limited failure. As each station is connected to the central hub with its own cable, therefore failure in one cable will not affect the entire network. Familiar technology. Star topology is a familiar technology as its tools are cost-effective. Easily expandable. It is easily expandable as new stations can be added to the open ports on the hub. Cost-effective. Star topology networks are cost-effective as it uses inexpensive coaxial cable. High data speeds. It supports a bandwidth of approximate 100 Mbps. Ethernet 100 BASET is one of the most popular star topology networks. Disadvantages of star topology: a central point of failure. If the central hub or switch goes down, then all the connected nodes will not be able to communicate with each other. Cable. Sometimes cable routing becomes difficult when a significant amount of routing is required. 4. Tree topology. 4. Tree topology. Tree topology combines the characteristics of bus topology and star topology. A tree topology is a type of structure in which all the computers are connected with each other in hierarchical fashion. The topmost node in tree topology is known as a root node, and all other nodes are the descendants of the root node. There is only one path exists between two nodes for the data transmission. Thus, it forms a parent-child hierarchy. Advantages of tree topology: support for broadband transmission. Tree topology is mainly used to provide broadband transmission, i.e., signals are sent over long distances without being attenuated. Easily expandable. We can add the new device to the existing network. Therefore, we can say that tree topology is easily expandable. Easily manageable. In tree topology, the whole network is divided into segments known as star networks which can be easily managed and maintained. Error detection. Error detection and error correction are very easy in a tree topology. Limited failure. The breakdown in one station does not affect the entire network. Point-to-point wiring. It has point-to-point wiring for individual segments. Disadvantages of tree topology: difficult troubleshooting. If any fault occurs in the node, then it becomes difficult to troubleshoot the problem. High cost. Devices required for broadband transmission are very costly. Failure. A tree topology mainly relies on main bus cable, and failure in main bus cable will damage the overall network. Reconfiguration difficult. If new devices are added, then it becomes difficult to reconfigure. 5. Mesh topology. Mesh technology is an arrangement of the network in which computers are interconnected with each other through various redundant connections. There are multiple paths from one computer to another computer. It does not contain the switch, hub, or any central computer which acts as a central point of communication. The Internet is an example of the mesh topology. Mesh topology is mainly used for WAN implementations where communication failures are a critical concern. Mesh topology is mainly used for wireless networks. Mesh topology can be formed by using the formula, number of cables equals, n*n1/2, where n is the number of nodes that represents the network. Mesh topology is divided into two categories: fully connected mesh topology, partially connected mesh topology, full mesh topology. In a full mesh topology, each computer is connected to all the computers available in the network. Partial mesh topology. In a partial mesh topology, not all but certain computers are connected to those computers with which they communicate frequently. Advantages of mesh topology: reliable. The mesh topology networks are very reliable, as if any link breakdown will not affect the communication between connected computers. Fast communication. Communication is very fast between the nodes. Easier reconfiguration. Adding new devices would not disrupt the communication between other devices. Disadvantages of mesh topology. Cost. A mesh topology contains a large number of connected devices such as a router and more transmission media than other topologies. Management. Mesh topology networks are very large and very difficult to maintain and manage. If the network is not monitored carefully, then the communication link failure goes undetected. Efficiency. In this topology, redundant connections are high, that reduces the efficiency of the network. 6. Hybrid topology. The combination of various different topologies is known as hybrid topology. A hybrid topology is a connection between different links and nodes to transfer the data. When two or more different topologies are combined together is termed as hybrid topology, and if similar topologies are connected with each other will not result in hybrid topology. For example, if there exists a ring topology in one branch of ISSI Bank and bus topology in another branch of ISSI Bank, connecting these two topologies will result in hybrid topology. Advantages of hybrid topology: reliable. If a fault occurs in any part of the network, will not affect the functioning of the rest of the network. Scalable. Size of the network can be easily expanded by adding new devices without affecting the functionality of the existing network. Flexible. This topology is very flexible, as it can be designed according to the requirements of the organization. Effective. Hybrid topology is very effective, as it can be designed in such a way that the strength of the network is maximized and weakness of the network is minimized. Disadvantages of hybrid topology: complex design. The major drawback of the hybrid topology is the design of the hybrid network. It is very difficult to design the architecture of the hybrid network. Costly hub. The hubs used in the hybrid topology are very expensive, as these hubs are different from usual hubs used in other topologies. Costly infrastructure. The infrastructure cost is very high, as a hybrid network requires a lot of cabling, network devices, etc. Cat 5 Cat 6 cable. A Cat 5 or Category 5, 5E, or 6 dash is an Ethernet cable, or cabling used to support computer networks. It can transmit video and telephony signals in addition to standard computer data. The Cat5 is usually the bare minimum required for hosted VoIP. Cat6 cables are designed for operating frequencies up to 250 MHz, compared to 100 MHz for Cat5e. This means that a Cat6 cable can process more data at the same time. Think of it as the difference between a 2A and a 4-lane highway. Difference of straight-through and crossover cable. Ethernet cables can be wired as straight-through or crossover. The straight-through is the most common type and is used to connect computers to hubs or switches. They are most likely what you will find when you go to your local computer store and buy a patch cable. Crossover Ethernet cable is more commonly used to connect a computer to a computer and may be a little harder to find since they aren't used nearly as much as straight-through Ethernet cable. T568A and T568B wiring standard basis ARJ45 connector is a modular 8-position, 8-pin connector used for terminating CAT5E patch cable or CAT6 cable. A pinout is a specific arrangement of wires that dictate how the connector is terminated. There are two standards recognized by ANSI, TIA, and EIA for wiring Ethernet cables. The first is the T568A wiring standard and the second is T568B. T568B has surpassed 568A and is seen as the default wiring scheme for twisted pair structured cabling. If you are unsure of which to use, choose 568B. T568A and T568B wiring standard basis straight-through vs crossover cable. A straight-through cable is a type of twisted pair cable that is used in local area networks to connect a computer to a network hub such as a router. This type of cable is also sometimes called a patch cable and is an alternative to wireless connections where one or more computers access a router through a wireless signal. On a straight-through cable, the wired pins match. Straight-through cable use one wiring standard, both ends use T568A wiring standard or both ends use T568B wiring standard. The following figure shows a straight-through cable of which both ends are wired as the T568B standard. A crossover Ethernet cable is a type of Ethernet cable used to connect computing devices together directly. Unlike straight-through cable, the RJ45 crossover cable uses two different wiring standards. One end uses the T568A wiring standard, and the other end uses the T568B wiring standard. The internal wiring of Ethernet crossover cables reverses the transmit and receive signals. It is most often used to connect two devices of the same type, e.g. two computers, via network interface controller, or two switches to each other. Straight-through vs crossover cable, which to choose? Straight-through vs crossover cable, which one should I choose? Usually, straight-through cables are primarily used for connecting unlike devices. And crossover cables are used for connecting alike devices. Use straight-through Ethernet cable for the following cabling: switch to router, switch to PC or server, hub to PC or server. Use crossover cables for the following cabling: switch to switch, switch to hub, hub to hub, router to router, router Ethernet port to PC, NIC, PC to PC. Conclusion on straight-through vs crossover cables. Straight-through and crossover cables are wired differently from each other. One easy way to tell what you have is to look at the order of the colored wires inside the RJ45 connector. If the order of the wires is the same on both ends, then you have a straight-through cable. If not, then it's most likely a crossover cable or was wired wrong. At present, the straight-through cable is much more popular than crossover cable and is widely used by people. FS.com provides a full-range straight-through CAT5E, CAT6, CAT6A, and CAT7 Ethernet cables with many lengths and colors options.